Unit 6, Lesson 3, Using Trig to Find Missing Sides. So in Part A, we're asked to use the given diagrams in order to find the ratios for sine of D and sine of A. So we'll start with sine of D. So the angle is D, and we know that sine is opposite over hypotenuse. So the hypotenuse is across from the 90-degree angle, and across from angle D is the opposite. So that means the ratio of sides is 7/14 for sine of D. And for sine of A, that's equal to opposite, which is 5, over the hypotenuse of 10. So we are asked to reduce the ratios. They both equal 1/2. Which makes sense because they have the same angle measures, yet they have a different size. So that means they're both similar. So they would have the same ratio. In Part C, would this also work for cosine and tangent? Well, let's check and see. Cosine of D is equal to adjacent over the hypotenuse. And cosine of A is equal to adjacent over hypotenuse. We can reduce those. So this is radical 3 over 2. And we can reduce this, and this is radical 3 over 2 as well. So it seems to work for cosine of D, as well as cosine of A. And I bet it's probably going to work for tangent as well. So tangent of D is opposite 7 over adjacent 7 radical 3. And tangent of A is equal to opposite, which is 5, over adjacent 5 radical 3. And as you can see, these two cancel out, in which case I'm left with 1 over radical 3. And the same thing goes for tangent of D. So yes, this works. The reason as to why this works, as I had mentioned to you earlier, is that these two are similar triangles, and as a result of a dilation, we know that we have same angle measures, yet sides are in proportion. If you haven't noticed that already, that seems to be the running theme. So we've been working with trig ratios for sine, cosine, and tangent. We will now use our calculators to find the values of sine of theta, cosine of theta, and tangent of theta. Your graphing calculator must be in degree mode to be able to calculate the trig values, since they are all degree measures. There's so much that goes into a unit circle, and this is going to be the first time that you are going to be working with this. This is the very basics, very, very basics of a unit circle, and there is so much to a unit circle, way more than what we are going to touch on, but you'll see a lot more of that in Algebra 2 Trig, and that will be a very exciting time. There's a couple of things that you need to take a look at. With regard to a unit circle, if you look at this radius right here, that value has a measure of 1. So the radius is equal to 1. You can drop a perpendicular, so we will do that right here. That creates a right angle. And no matter where that radius is on this unit circle, you can always drop a perpendicular and get a right triangle. In addition to that, we have angles that are created here. So there are many angle measures we can make, and it starts from 1 degree and it goes all the way up to 90 degrees. So I'm going to erase this for right now, go back to the basics. So if we do go all the way up to 90 degrees, then we have the right angle that's in here. And as you can see, this line is perpendicular and we get the right angle. If you compare this to a clock that was going in a counterclockwise direction, and this as the minute hand, it continually can go round and round and round and round. But you don't need to write that right now. We're just going to look at the first quadrant, which is right here. And in addition to that, we have x and y values. So these points where the radius hits are x and y values, as I stated earlier, but you'll get to know them later on, not now, and you don't have to write this down either, as cosine of an angle, sine of an angle. These are your values for x and y. And you'll understand later on again where we get these values from pertaining to a unit circle, and you've already been learning some of the basics that will get applied to the unit circle, but for right now, all they're asking us to do is use our calculator in order to find the approximate values. You're going to get decimals in most cases, not all, and you're asked to round to the nearest 10,000ths. So for number 2 here, we drop a perpendicular. Okay, again, that will come later on. You're not necessarily going to be using this information directly at this stage in the game. The radius reminds you of a minute hand of a clock. And x and y values, the coordinates are represented as cosine of theta, sine of theta. And hopefully later on in your math life you might remember that. That would be pretty cool. Okay, so in your calculator, the first thing you need to check to see is if you are in degree mode. So you're going to have to hit the home button on your calculator. Click the number 5 settings button or icon. Then select choice 2 document settings. Take a look at the angle. Make sure it's in degree. If not, select it. And make sure you press enter. As a final step, just make sure you check the display digits, which is above the angle function, so that it's floating at 6. Okay, so now going back to putting this in the calculator, you're going to go to the calculating icon. You're going to click sine, which is the trig function. The trig button is to the left of the number 7 on your calculator. So you click that and you select sine, hit enter, and you're going to put in the first angle measure. If you look here, these are all the given angle measures in which we were going to find by plugging into the calculator. So sine of 0, that is an angle measure of 0, which is represented by this line up here, if you see where I'm drawing the blue in the circle. If you put that in your calculator, you're going to get the value equal to 0. So trig, which is the button to the left of 7, 0, enter, you'll get an output of 0. So now we go up to 10 degrees. Oh, let's put on cosine of 0 though. Cosine 0 is equal to 1. Okay, so 10 degrees is up a little bit. Then we go up another 20 degrees. We go up to 30 degrees. Right now, this radius extended out to the circle is about a 45-degree angle. It looks like it's cutting this right angle in half. So from here to the radius is about a 45. So we're looking at all the angle measures within this quadrant. So put in your calculator sine 10, click enter, and hopefully you got the same result as I did, which is 0.1736. We're rounding to the nearest 10,000, so that's 4 decimal places to the right. Do this for cosine. So trig button to the left of 7, select cosine, put in 10, hit enter. And the 10 or any of the angle measures go in between the parentheses. And you should get 0.9848. Fill in the rest of the boxes by finding the sine and cosine of the remaining angles. And don't forget to round to the nearest 10,000th spot. That's very important. In addition to that, compare your answers to mine when you're done. So go ahead and press that pause now. So here are all the values that you were supposed to get, and hopefully you did get them and you rounded correctly. I'd like for you to pay a little bit extra special attention to values that are the same, and hopefully you're able to remember the reasons as to why they are the same. The sine of 50 is the same value of the cosine of 40, and as we know, the acute angles of a right triangle are complementary. So the values of their angles, 40 and 50, is equal to 90. Okay, and we see that with the 30 and the 60. The sine of 60 is equal to the cosine of 30, and vice versa. We have the sine of 80 is equal to the cosine of 10. The sum of 10 and 80 equal 90. And the same goes for 70 and 20. As you can see, the sine of 70 is equal to the cosine of 20. And the sine of 20 is equal to the cosine of 70. Okay, so we're asked to consider the given triangle. For example 2, we're going to use trig ratios in order to find the length of side A to the nearest hundredth. Got to pay attention to that. Okay, so we're going to have to use trigonometry, sine, cosine, or tangent because we're given angle measures and we're looking for a missing side, and we have 2 missing sides. So using the angle measure of a right triangle and one of the sides, we're able to find the other side. So that's going to make a difference in whether we're going to use Pythagorean's theorem or trigonometry. One thing that may help you to remember the trig functions is something called Sohcahtoa. 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 So sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. You're going to have this memorized. So this is one way to do it. We just memorize Sohcahtoa, and I'll quiz you on that just to check to see if you know how to spell it. You have to know how to spell it correctly in order to use it. So if we take a look at the given triangle, we see that the hypotenuse is given. Always locate the hypotenuse first. That never changes. And you can use either one of the two angle measures. I'm going to go with 40, and I'm going to use the opposite side because that's what we're looking for. So now we set it up. The sine of 40 degrees is equal to A, the length of the side that we're looking for, over the hypotenuse of 26. In order to find what A is, we're going to cross multiply here. So we get 26 sine of 40 is equal to A. Plug that into the calculator exactly the way that you see it, and we're going to get the value for A. Go ahead and do that now. So yes, the answer is 16.71 is the approximation for the length of the side for A, rounded to the hundredth spot. Now we want to calculate the length of side B to the nearest hundredths. You could either use a trig function or Pythagorean's theorem. That's entirely up to you. I particularly like to use trigonometry. So cosine of 40 is equal to B over 26. Cosine of 40 is equal to B, and the approximation for that is, go ahead and calculate that. Yep, 19.92. So what other method other than trig can be used to determine the length of the side of B? I just stipulated that, Pythagorean's theorem. That's entirely up to you. There's other trig functions that we could use. You could use the angle measure of 15, set up a trig ratio regarding that. So you have a variety of options. It's just a matter of you selecting what you're most comfortable with. Okay, so we want to find the lengths of the sides of some right triangles, and we're going to use trig functions. You're going to have to figure out which one you want to use. I would go ahead and write Sohcahtoa. Okay, so I have this angle measure of 42. I have the side that's opposite, and I also have the hypotenuse. If you want, just go ahead to every single triangle, or right triangle that is, and label it. Label the H, so we can distinguish that from the rest. So since I have an opposite and a hypotenuse, or I'm looking for the opposite and I have the hypotenuse, I'm using sine. So sine of 42 is equal to x over 18. Cross multiply. And to the nearest hundredths, tell me what the approximation is. And hopefully you got 12.04, which I think you did. You guys are good like that. Okay, looking at number 2, I'm looking for the hypotenuse. Here's my angle. The side opposite the angle is here, so the only one that's left is the adjacent. So the function that uses the adjacent and the hypotenuse is the cosine function. So cosine of 28 degrees is equal to 6 over the hypotenuse of x. So since x is in the denominator here, what I'm going to do is switch x and cosine of 28. In cross multiplication, that's what you would end up with. So instead of doing all of that work, which you've been tested on years ago, we're just going to go ahead and switch with the knowledge that we were able to do this because of cross multiplication, otherwise known as the product of the means is equal to the product of the extremes. So go ahead and put that in the calculator. Control divide, put the 6 in the numerator, trig button, cosine, 28 in the parentheses, hit Control Enter. And you should get the decimal approximation to 6.80. For number 3, here's the angle. The side opposite is x, and the other side is my adjacent. So the trig function that deals with the opposite and the adjacent is the tangent function. So tangent 63 is equal to x over 34. X is in the numerator, so all I have to do is cross multiply. It's 34. Tangent of 63 is equal to x. So put that in your calculator and figure out what that value is. Yep, you got it, 66.73. And last but not least, number 4 here. My angle is 50. The hypotenuse is what I'm looking for, and it's the opposite that I'm given. So that deals with the sine function. So sine of 50 is equal to 123 over the hypotenuse x. Again, x is in the denominator, so I'm going to go ahead and switch x with sine of 50. Put that in the calc and find out what the approximation is equal to. Go ahead and do this now. You got it, 160.57. Now an application to real life. An 8-foot rope is tied from the top of a pole to a stake in the ground as shown in the diagram pictured. If the rope forms a 57-degree angle with the ground, what is the height of the pole to the nearest tenth of a foot? So we have to make sure that remember to round to the nearest tenth. We got to figure out what the height of the pole is, so that's our x. And in relation to the angle that's given, as well as the hypotenuse, we know that this is the side that's opposite the given angle. So that's the sine function. So sine of the angle 57 is equal to the opposite side over the hypotenuse. Go ahead and cross multiply and find out what the approximation is. Indeed, that answer is 6.7, rounded to the 10th spot. You are now at the end of this lesson. It is your responsibility to complete the homework that's attached and hand it in for a grade.